Hello everybody, and welcome to your linear algebra review on solving a matrix equation. My name is Jason, and I work for the ASU Tutoring Centers. Now, in this, we're trying to solve for the matrix Y. If we look at what the equation looks like, Y is over here on the right-hand side all by itself. So really solving for Y comes down to simplifying this big equation right here. So we're essentially going to be looking at all the properties we discussed in previous videos, so matrix addition, scalar multiplication, and matrix multiplication, and we're going to be doing all of them together all at once here. Okay, so let's start by just substituting in the values that we have. So it's beta times alpha A plus BC, where alpha is this, beta is that, and A, B, and C are these matrices. So let's just substitute those values in real quick. So we have Y equals beta, which is 6, times alpha, which is 1/2, times the matrix A, plus B, so 2, -1, 3, 1, times the matrix C. 1/2, oops, 1/2, -1/2, 0, and 1. Still messy. Here we go, 1/2. Okay, so this is what we're trying to do. So again, it comes down a lot to what you learned in regular algebra. PEMDAS, right, the order of operations. You want to do parentheses first. So there's a couple ways we can do this. We can simplify inside here first, and then multiply that matrix that we get out of there by 6. Or alternatively, we could distribute the 6 in, and then do all of our operations afterwards. I'm going to do that approach. I'm going to distribute this 6 in. So I'm going to take this 6 times this matrix here, this 1/2 times matrix A. So the 6 and the 1/2 together will now become 3 times this matrix, plus, and then I'm going to distribute the 6 over here. 6 times 2, -1, 3, 1, times 1/2, -1/2, 0, and 1. So now again, there's a couple different options we have here. We can choose to multiply the 6 into this matrix here, and then do the matrix multiplication, or we can do the matrix multiplication right now, and then multiply the 6 in afterwards. I personally would like to do the matrix multiplication first, just to get that multiplication out of the way before we start making the numbers bigger by multiplying by 6. So let's do this matrix multiplication first. So we're going to be multiplying these two matrices together. First of all, can we multiply them together? Well, the first matrix is a 2 by 2, and the second one is also a 2 by 2. So because these middle two numbers match, they both have 2's, we can multiply them together, and our resulting matrix would be a 2 by 2 matrix. So let's see that in action. I'm going to leave everything else the same. So I still have 3 times 1, 2, 4, -6, plus 6 times. Okay, so let's do our matrix multiplication. So remember how it works. It's rows times columns. So if I take my first row times my first column, so I'd have 2 times 1/2 plus -1 times 0. And then I would take my first row times my second column. So I have 2 times -1/2 plus -1 times 1. And then I'm going to go ahead and move down to my second row. So I would have 3 times 1/2 plus 1 times 0. And then I'm going to have 3 times -1/2 plus 1 times 1. Cool. Okay, so now I'm going to do some erasing, just so I have a little more room. Keep in mind, this is all what Y equals, so all this we're doing is simplifying just to solve for what Y is. So I'm going to go ahead and continue it up here. So I would have 3 times the matrix 1, 2, 4, -6, plus, let me do a better 6 there, plus 6 times the matrix. So now let's just simplify this. So our first term, 2 times 0.5 is 1, -1 times 0 is 0, 1 plus 0 is 1. And then we're just going to keep doing that process for all of these. So this gives me -1 minus 1, so that's -2. This gives me 1.5 plus 0, so it's 1.5. And this gives me negative 1.5 plus 1, so negative 0.5. Cool. Now I can go ahead and do my scalar multiplication. So I'm going to go ahead and multiply this 3 by this matrix and this 6 by this matrix. Remember, scalar multiplication is done component-wise, so I have to multiply this 3 by every element in my matrix. So I'd have 3 times 1, 3 times 2, 3 times 4, and 3 times negative 6. And similarly here, I'd have 6 times 1, 6 times negative 2, 6 times 1.5, and 6 times negative 0.5. And now I'm adding these two matrices together. So remember, you add component-wise. So I would do 3 plus 6, which is 9. I would do 6 plus negative 12, which is negative 6. I would do 12 plus 9, which is 21. And I would do negative 18 minus 3, which is negative 21. There is your final answer. So this is what the matrix Y equals. So again, this exercise was more so just culminating everything that we had been working on. So matrix multiplication, scalar multiplication, and matrix addition, and doing it all together in one. Okay. And keep in mind, so the way that we did it, right? We chose to do the matrix multiplication first, but we could have done the scalar multiplication first, and then multiplied the matrices together. So there's not always one clear-cut way to do these problems, but there are certainly incorrect ways to do them, right? Like we wouldn't want to be adding matrix A to matrix B first before we've actually done the simplifying of this matrix multiplication and this scalar multiplication. So still make sure you follow the rules of PEMDAS. Do your multiplications first, and then you can do your matrix additions. Wonderful. All right, over here on this slide, I have a little more information. So as I mentioned, I work for the ASU tutoring centers. If you want more information about the free resources we have on all 4 major campuses and online, go ahead and check out tutoring.asu.edu. If you want more information like this one that I provided in this video, where I went over specific concepts in your course, or maybe you want to see what upcoming review sessions we are going to have, you can go ahead and check out that link down below, the tutoring.asu.edu/student-services/reviews. Thank you all very much, and have a wonderful day. Oh my God, are you kidding me? Oh, God.